If we look at Agarwal-Gardner, this is another approach that's very similar to Blasingame. And we use it just to provide a little bit different perspective. Very often these two will give the same answer. But the Agarwal-Gardner approach has a nice added feature where we can put this raw data derivative on. And it gives us some additional information. For example, it shows us very clearly that we've achieved boundary dominated flow, maybe even before it's clear in the raw data itself. Once we see a unit slope on the derivative plot, we're fairly certain we've achieved boundary dominated flow. In addition to that, there's a feature in Agarwal-Gardner that allows us to show where boundary dominated flow begins in the raw data. And now you'll notice that some of these points are turning blue and some of them are turning red as I move the data around. Once I've chosen my desired location for the match, that point in time right there is the indicator where I've gone from transient flow into boundary dominated flow. The Agarwal-Gardner plot is the best way to pinpoint that location. And that can be very valuable information. Let me show you why. We'll put an arrow on here, and the arrow will indicate the point at which we've transitioned from from transient flow to boundary dominated flow. We can also show this on a regular linear plot of production data versus time and pressure data versus time. And we can see very clearly from this plot that there's only a very small amount of transient data, probably less than a month, before this well goes into boundary dominated flow. This is all boundary dominated flow after this point in time. That's something that would not necessarily be clear if all we were to do were to look at the linear production data. So the type curve adds a tremendous amount of value and allows us to determine that that is indeed all boundary dominated data. Now, why does it matter? Why do we care if it's boundary dominated flow data? Well, it makes a big difference because when we're evaluating reserves, once we've achieved boundary dominated flow, we have effectively observed all of the extents of the reservoir, which means that our reserve evaluation should have a fair degree of confidence. When we update that reserve evaluation next year or the year after, the process of adding additional data and updating the reserves shouldn't change our answer, in theory, if we've achieved boundary dominated flow. So in production data sets, achieving that boundary dominated flow and recognizing that from our type curve analysis is very important because it tells us when we ought to have high degree of confidence in our reserves evaluation and our evaluation of the in-place fluids. If we have not achieved boundary dominated flow and we're still in transient, then there is no way to determine with any degree of confidence what the ultimate recovery is going to be because we have not investigated all of the area of the reservoir yet. So the Agarwal-Gardner plot provides us a very nice way of figuring that out. Let's move on.